Welcome to Chem 327. This is just a short video to tell you something about the Open Labs part of the course. This is a period of 4 weeks from September 15 to October 8. And let me share my screen so that we can go through a discussion of what's happening in this 4-week period. So first of all, we'd like to be able to introduce you to 3 aspects of experimental work. The first part is about using a reasonably complex instrument, and this will be done by video. You can watch it on the class YouTube channel that's given out there, and it's also given in your Quercus and in the Discord channels. And then the second part, which is the longer part, which will last for 3 weeks, is to build a simple instrument and to prepare the sample for this simple instrument. And these are things that typically experimental physical chemists engage in. So let's just get started. Open Labs 1 is about using instruments for experiments, and these can be rather complicated instruments. And I show here 2 classes that we'll be looking into. The first one is imaging. This is being able to see what is the sample you're interested in, to look at the lateral dimension. Now, seeing doesn't mean necessarily by your own eye. It's about measuring a property across a lateral dimension. And if you can do that, there's so much you can learn about your sample. The other experiment that you will be seeing in your video is about spectroscopy. And I think you've encountered spectroscopy already, perhaps in your NMR and your IR in some of the other courses. It's about being able to look at the energy levels, the transition between energy levels, and to then learn about your sample by looking at the spectra. Now, spectroscopy is way beyond IR and NMR, and you can actually learn a little bit more in the videos. The videos were made by your TAs to show you the kind of experiments that they do in the lab, and so feel free to ask them more about it. And also feel free to read more and to think as you're looking at these videos, as you're watching the videos, about what kind of questions, what kind of ideas, what kind of samples are you actually interested in and why? And perhaps you may get a chance to use some of this equipment later. As a note, you should, after watching the videos, there's a little quiz. You should complete quiz 1 by September 21. Do this yourself. Do not get help from anyone. Do not discuss. You can use Google, you can use notes, you can watch the video within the period of the quiz, but don't have anybody help you. Okay, so the second part, Open Labs 2, is the bulk of Open Labs, which is about getting you to build a simple instrument. And there are 3 subsections on this. One instrument is about looking at surfaces and creating a simple contact angle measurement. You know, it's part of physical chemistry to actually be able to build an instrument, sometimes simple, sometimes complex, sometimes because the instrument doesn't exist, or sometimes the instrument exists, but you don't have it, or sometimes it's there, but you have a particular thing that you want to study in a sample that's more amenable by something you designed that's specific to what you're trying to measure. And so it's important to be able to learn how to do simple building. So you will learn some basic electronics and basic data acquisition. We'd like you to be able to get a little measurement and get the data into the computer without having to, furiously take down numbers as a function of time. Okay, and as part of Open Labs 2, you will have a mini project. You're asked to do a mini project that requires some data acquisition, some measurement to answer a simple question in your surroundings. And it has to be safe because we're not going to be doing Open Labs 2 in our lab. It will be done remotely. It can be in your room, it can be outdoors, wherever you feel comfortable doing it, but you have to be safe. Okay, so what to do? Pick up the kit. There is a kit, a plastic bag full of little pieces that is available in from LM Lashmiller room 503. I forgot to put it on the slide. Pick it up by September or on September 22. Inspect the kit to make sure that everything's there. Do not lose the parts. And please take care of the kits because the electronics parts in the plastic bag you have to return at the end of the course so that we can reuse them. Now, the labs will be synchronous but online. So you will not be in in-person labs. You will do work wherever you are. The TAs and I will be online in our Discord server for discussion during that lab period. And we may actually ask you to come and chat with us, or you may just decide to drop in. We will be sitting in our meeting rooms. We'd like you to post your activity, whether it's your results or the picture of what you had built or a question that you want. Please post. We're trying to actually simulate a real lab environment where you can talk to each other. We can talk to you by posting under the appropriate area there that says, open labs. You will build a contact angle device, prepare surfaces. There are some suggested surfaces that we've given you, but we'd like you to explore what is it that you're curious about in your surroundings, or in fact, if you can design and make surface coatings, that's wonderful. You record your data, and this will be part of quiz number 2, which you should do before October 5. And I have there a little competition that basically says, here's a challenge. What's the most hydrophobic or the most hydrophilic surface you can make? And I'll give you a bonus point for the winners of the challenge. And also for some, if you've done something that I consider unusually creative, you'll get a bonus point for it. And then you watch the videos on Open Labs 2, which is the electronics component. And there are some exercises that are suggested in that video. Get familiar with the components that were given to you, test them out, and then carry out a mini project that allows you to measure something. This is your chance. You have at least 3 different sensors in them. You can figure out what little question you can answer in your surroundings and gather the data, feed it into the computer. The videos are there to guide you, and there's actually a lot of other videos that you can look at in YouTube, but you should also feel free to discuss with your TAs. As I said, these labs are going to be done synchronously during the lab period that you signed up for in our Discord server. So we will be there to answer your questions and to help you out. Okay, now while you're doing all this, you should be the idea of a lot of these things is for you to be inspired to think of potential projects for your discovery labs. At the end of Open Labs 2, you have to prepare just a short report. The instructions are in Quercus. A short report that really summarizes what you did and why it's interesting, and then give us the picture of your setup and the data. Just something very simple, not a formal report. And with that, that's the instruction for Open Labs. And I hope you enjoyed the next several weeks of class before we move on to our discovery labs.